I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up four very important questions based on polynomials. We are working in the domain of complex numbers, right? So, polynomials in the domain of complex numbers. These four questions are normally seen in IB HL test papers, and I hope the strategies which we apply here will help you to answer many similar or even difficult test questions. So we'll try to understand what are complex numbers and how do we find roots of polynomials when complex roots are involved. We'll find square root of complex numbers. We'll also work with the cube of complex numbers. In solving these questions, the concept is to relate the real and the imaginary parts. That's the key. Well, let me thank all of you for supporting our channel and providing excellent suggestions. Keep supporting as we need to reach millions globally. Feel free to contact our email globalmathinstitute@gmail.com. We have been serving you absolutely free on YouTube for more than 15 years. Now let's take up the set of questions. Amazing, brilliant questions seen in past test papers. Question number 1. Show that the complex number I is a root of the equation given to you. And B is then find the other roots of the equation. Question number 2. We are given z over z plus 2 equals to 2 minus I, or sometimes iota we say, where z belongs to set of complex numbers in the form of, we need to find what z is in the form of a plus bi. Question number 3, to find the square root of minus 5 minus 12i. And question number 4 is to evaluate the value of 1 over 1 minus I square root 3, everything cube. You can always pause the video, answer these questions, and then look into the suggestions. Well, in case you want to learn directly from me, send an email on globalmathinstitute@gmail.com. Now, let's get ready for the IBHL math test, answering these questions in the best possible way. So, we'll begin with the very first one, which is we are given that x to the power of 4 minus 5x cubed plus 7x squared minus 5x plus 6 equals to 0. We need to show that the complex number I or iota is a root of this equation, right? So when I say I is the root of this equation, it means what? It means that the polynomial value for I should be equal to 0. So we are going to substitute I for x, right? So basically, we'll substitute x equals to I and then evaluate. So we get I to the power of 4 minus 5 times I cube plus 7 times I squared minus 5 times I plus 6 equal to 0. So that should be true, right? So I to the power of 4 is plus 1 minus 5I cube is minus I, right? So this is minus I square is minus 1, correct? And this is minus 5I plus 6. We need to show that this is equal to 0. We get 1 minus, and this becomes plus 5I. Here we get plus 7. Here we get minus 5I. Then we plus 6 equal to 0, correct? We see, yes, it is true, right? Since this is minus 5I, so we see these two terms, which are plus and minus 5I, cancel. And so what do we get here is 0 equals to 0, right? Therefore, we have shown that I is the root. Correct? Now remember one thing, if I is the root, then minus I is also the root. They are always in conjugate pairs, right? So complex roots are in conjugate pairs. Let's write down. Complex roots are in conjugate pairs. Clear? So with that, let's begin to part B, where we have to find the other roots. So now you know that both I and I square minus I, both are roots, right? So we need to find the other roots of this particular equation. How are you going to figure it out? Well, since we know that plus and minus I are roots, we can say that x squared plus 1 is a factor, right? Now that's the key to understand. So if I divide by x squared plus 1, I get quadratic equation. And then I can find the other two roots, which are real in this case, right? Since we know that x squared plus 1 is a factor, we are going to divide this polynomial by x squared plus 1 to get the other factors, correct? So let's do that. So we have x to the power of 4 minus 5x cubed plus 7x squared minus 5x plus 6. We are going to divide this whole equation by x squared plus 1. Let us write 0x plus 1. This is a placeholder, right? Okay, so we'll take three terms and we can multiply by x squared. So we get x to the power of 4 minus 0x cubed plus x squared. So when you take away, what do you get? You get minus 5x cubed, and here you get plus 6x squared. Bring down minus 5x. So now you can take in quotient minus 5x, right? So minus 5x will go here. So we get minus 5x cubed minus 0x squared, and this gives you minus 5x. And here we get 6x squared. So that is 0, right? They cancel away, right? And then we have plus 6. And now we can multiply by 6 to get 6x squared plus 6. And as expected, the remainder is 0. So basically, we have the other roots, which I can now write as x squared minus 5x plus 6. 3 times 2 can work for us, so minus 3 times x minus 2. Right, so the roots are x equals to 3 and at x equals to plus 2, correct? So find the roots of this equation. So we know the other roots are 2 and 3, right? So we know our answer now. The roots are plus minus I, which we found earlier. The real roots are 3 and 2. Does make sense to you? So basic concept, as you see, is that once we know one complex number is the root, the other conjugate will also be the root. Then you divide by their factors and get the others, as we did here. So I hope this concept is absolutely clear. Now let's move on and take the second question, which is given that z over z plus 2, let me rewrite this. We are given that z over z plus 2 is equal to 2 minus I. Find z in the form of a plus bi, right? So we have to find what is z in this particular case. Now there are a couple of ways to do it. I'll do one solution and I can give you suggestions for the other. So to find the value of z, let's isolate it, right? So we'll cross multiply, so we can say z equals to z plus 2 times 2 minus I. So I crossed z so that there's no confusion between the number 2 and the alphabet z. So we have z equals to, open the bracket, 2z minus zi plus 4 minus 2I. So taking z's together, we have We can put the z's on the one side, so we get 2z minus z, right? Minus zi equals to, we have minus 4 plus 2i. Correct. Now, 2z minus z is z, so we get z minus zi equals to minus 4 plus 2i. We can take z common, so we get 1 minus I equals to minus 4 plus 2i. So z is equal to minus 4 plus 2i over 1 minus I. Now, we need to actually write it in the form of a plus bi. So in that case, what should we do? We should multiply by the conjugate, right? So that should help us. So let's multiply by conjugate. So z equals to minus 4 plus 2i over 1 minus I will multiply and divide by 1 plus I. Okay. So you get minus 4i plus 2i, and 2i times I will give you minus 2, right? And in the denominator, we are going to get 1 square minus I square, correct? So that gives you minus 4 minus 2 gives me minus 6, and minus 4i plus 2i gives me minus 2i over 1 square minus I square. Now I square is negative 1, right? So we have 1 minus 1, which is 2, right? So we have here 1 minus minus 1, and so combining, we'll get this answer as equal to, dividing by 2, so we get minus 6 minus 2i divided by 2, right? So we get 3 minus 3 minus I as our answer, correct? So we get minus 3 minus I as the complex number z in this particular case. Make sense, right? So that is how we are going to solve this particular question, correct? Okay. So we have one solution here. I will recommend you to also take into consideration the next alternate method. Let's give you that. So what you can do is you can write z in the form of a plus bi and then expand and simplify, right? So in that case, you will have an equation a plus bi over a plus bi plus 2 equals to 2 minus I. Now, when you cross multiply and expand, in that case, you equate real parts and imaginary parts, right? You will get the same answer which we got, which is z equals to minus 3 minus I. Make sense? So I like you to try this out. Perfect. Now here is the third question for us. We need to find square root of minus 5 minus 12y. So basically we need to find square root of minus 5 minus 12y. How will you do this? I hope you're enjoying the journey. Feel free to send your comments and suggestions. And in case you want to learn from me, send an email on globalmathinstitute@gmail.com. You can also visit our website for more details. Right. So now what we will do here is that we need to find square root, right? We need to find square root of this. So I wrote square root, and let this square root be a plus bi. The best way is just square both sides, right? So if I square both sides, I get minus 5 minus 12i equals to a plus bi whole square, right? So we have minus 5 minus 12i equals to a square plus 2ab I plus b square, which is bi whole square, right? So we get minus 5 minus 12i equals to a square. Now see, 2abi is a complex term. Bi square will give you minus b square, since I square is 1, and here we have 2abi, right? Now in the second alternate solution, we told you to compare real and imaginary part and then solve. The reason is that we are going to adopt this strategy right here in this particular case, right? So here you see the real parts. Real parts are a square minus b square, and that is same as minus 5. And the imaginary part is 2abi, which should be minus 12. So that gives us the two equations to work with. You get the idea, right? So from here, we can write that minus 5 is actually equal to a square minus b square, and we can write that minus 12 is equal to 2ab. You get the idea, right? So 2ab is minus 12, that means minus 6 is ab. I can write minus 6 by b as equals to a. And once I have that, I could, let's call this as equation 1, equation 2, and now this as equation 3. Substituting the value of a as minus 6 over b in the first equation, we get minus 5 equals to, instead of a, I'm writing minus 6 over b whole square, right? Minus b square. You get the idea. So we have minus 5 equals to 36 over b square minus b square. So we have a quadratic equation in b, and from here we can actually solve for b and get the value, right? And then find a using a is 6 over b negative. Perfect. So let's go to the next page. We have minus 5 equals to 36 over b square minus b, right? So what we'll do basically is that we'll multiply by b square all the terms. Let's do it on the next page. So we have minus 5 equals to 36 over b square minus b square, right? So that's the equation. We'll multiply by b square, so we get minus 5b square equals to 36 minus b to the power of 4. So that gives us an equation which is of degree 4. Bringing all the things to the left side, we get b to the power of 4 minus 5b square minus 36 equals to 0. Now this can be factored, right? 9 times 4 is 36, and so we could write this as b square minus 9 times b square plus 4, right, equals to 0. That gives you that b square should be equal to 9 or b square equals to minus 4, right? So these are the two possibilities of b, right? Now, of course, b square cannot be negative as real, so we'll end up with b square equals to 9, which gives us b as equal to plus or minus square root of 9, which is plus or minus 3. Correct. Also note that we had a equals to what? So a is equal to minus 6 by b, right? So a is minus 6 by b. So we could consider plus and minus b. So we get minus 6. If I say plus 3, right, then I get minus 2 as the answer. But if I write minus 6 divided by minus 3, I get plus 2 as my answer. And therefore, the square root of minus 5 minus 12i can be written as, we could have two square roots, right? So let me write both of them as a is minus 2 when b is plus 3, right? So plus 3i, or when a is positive 2, it is minus 3i, correct? So these are the two square roots for the given equation, and that is how we are going to solve it. So I hope these steps are absolutely clear, right? Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Feel free to send an email on the address given for more details. Here is the last question for you. I'd like you to look into this. We are going to take this up as a solution of this in the next video. Perfect. So wait till then. The next video will be uploaded tomorrow. Thanks for your time and all the best.